Hey guys, Mr. B here. In this video, we're going to be going over the balancing and writing chemical equations worksheet. I don't know if I'm going to do every single one of these problems, but at least we're going to do quite a few just to make sure that you have an understanding of what's going on. So in this first part here, they give us a bunch of chemical reactions. Our job is to balance them and then determine what reaction type they are. All right, so for balancing, let's start with number one. Usually when you balance, you want to make like a little list on both sides of the reaction of how many of each thing you have. It makes it easier to balance that way. So I'm going to kind of do that down below here. So on the left side of this reaction, we have one mercury and we have one oxygen. On the right side of our reaction, we have one mercury and we have two oxygen. All right, so very clearly we can see that the oxygens are not balanced. We have two on the right side of our reaction and only one on the left. So we are going to need to put a 2 here to give us two oxygens. That also, though, now is going to change our mercuries from being 1 to 2. So on the right side, we're also going to need to have a 2 here to balance out the mercuries because we just unbalanced them. And then if we look at both sides, we should see that we have 2 of each on both sides. So it should be good to go. As for the reaction type, this is going to be a decomposition reaction. We're starting with one reactant and it's breaking apart into 2 different products. So that is a dead giveaway. That is decomposition. You know, we're just gonna write decomp just to make it a little bit shorter. So, all right, taking a look at number 2. Again, let's make a little list. So on the left, we have one mercury. One mercury, one chlorine, and we have one magnesium. Oh, I just realized that that should be HCl, not Hg. There you go. I was like, this doesn't make any sense. There you go. One hydrogen, one chlorine, one magnesium. On the right side, we have 2 hydrogens. 2 chlorines and 1 magnesium. So the hydrogens and the chlorines are not balanced. So let's balance the hydrogens first. On the left side, we need to have 2. So let's put a 2 here. That will give us 2 hydrogens. That will also give us 2 chlorines. And on the right-hand side, that balances out with the 2 hydrogens and the 2 chlorines you already have. The magnesiums are just fine. So balancing wise, this is all we need to do. And as for reaction type, this is going to be a single replacement reaction. We can see that we have hydrogen here in this compound with chlorine, and the magnesium kicks the hydrogen out. So in the product, hydrogen is by itself, magnesium is now paired up with chlorine. So that is a single replacement reaction. And let's just write SR just to keep it simple. So all right, taking a look at number 3. So again, let's count. So we have 1 carbon, 4 hydrogens, 2 oxygens. And on the right, we have 1 carbon, we have 2 hydrogens, and we have 3 oxygens, okay? So we have to count the 2 that are on this compound and then the 1 that is there. So total, right, if you count all of them together, that's 3 total oxygens. All right, so I'm going to balance out the oxygens last. So usually, a little trick, usually when you have an element that's in 2 different places, it's hard to balance because you have to put numbers in different locations and then things change really fast. So it's probably easier to balance out the carbons with the hydrogens first and then see if the oxygens just kind of happen to fall into place. So the carbons are already balanced, but the hydrogens are not. On the right side, we have 2. On the left side, we have 4. So we're going to need to put a 2 here to give us 4 hydrogens. That will also change the number of oxygens we have. So this 2 is going to multiply these oxygens by 2. Okay, so that's going to give us 2 oxygens there, plus the 2 oxygens we have there. So that's going to give us a total of 4. So on the left-hand side, our hydrogens are balanced, our carbons are still balanced, but our oxygens are not. So we have 4 oxygens on the right, we only have 2 on the left. So we're going to need to put a 2 in front of this compound to give us a total of 4 to balance everything out. Okay, so this is going to be our balanced equation. As for the reaction type, this is going to be a combustion reaction. Oh, that's what I didn't want to do. There you go. It's going to be a combustion reaction. Combustion have a very specific chemical equation, where you're usually going to have some kind of carbon-based compound reacting with oxygen, and you're making CO2 and water. Okay, that is like dead giveaway. This is combustion, hands down. There's nothing else it can be. So if we look at number 4 pretty much looks exactly the same as number 3. The only difference is this carbon-based compound is different than this one, but otherwise everything else is exactly the same. So for number 4, we can already tell that this is going to be another combustion reaction. All right, as for balancing again, let's take a look here. So we have 6 carbons, 12 hydrogens, and as for oxygen, we have 6 here, plus we have 2 there, so that is a total of 8 oxygens. On the right-hand side, we have 1 carbon, 2 hydrogens, and again, we have 2 oxygens here, and 1 oxygen there, so that's a total of 3. All right, so again, another tricky one. Again, we'll deal with the oxygens last because they're in 2 different places. Let's deal with the carbons and the hydrogens first. So on the left we have 6, on the right we have 1. We need to put a 6 here to balance out the carbons. Okay. We can update our oxygens, but let's just ignore them for now and move on to hydrogen. So carbons are good. Hydrogens on the left we have 12, on the right we only have 2. So we need to put another 6 here to give us 12 hydrogens. All right, now as for oxygens, let's see. So on the left, nothing changed. On the right, we have 6 times 2 here, so that's 12. Okay, so that's 12. Plus 6 times 1 is 6. So we have 12 here, 6 there. That gives us a total of 18. Okay, 18 oxygens. So on the left, we have 8. Now, if we put any number here, okay, so if we put a number in front of this compound, that's going to mess up both of our numbers for the carbons and the hydrogens on the right. So no matter what, we do not want to put a number in front of this compound, but we can put a number in front of this oxygen because that only changes the number of oxygens. Okay, so that won't change anything other than just the oxygens. So we have 18 on the right, we have 8 on the left, 6 of them are here. So basically we need to have 6 oxygens plus some other number of oxygens equals 18. Okay, that's what we need to do, right? We have 6 here plus some number here. So this needs to be 12. 6 oxygens plus 12 oxygens will give us a total of 18. There's 2 of them here, which means that in order to make this a 12, we need to put a 6 here. Okay, so 6 times 2 gives us 12 oxygens in this part right here, 12. Plus this 6 gives us a total of 18 oxygens, which then would balance out with the 18 oxygens we have on the right side. Okay, so that one's a little bit tricky. Hopefully that makes sense. And reaction type we already have down as combustion. All right, number 5. Again, let's make a list. So we have 2 H's, 2 O's. On the right, we have 2 H's, 1 O. So we can see that the oxygens are not balanced. We need to put a 2 here. That'll balance those out. That then gives us 4 hydrogens, which means over here we need to have a 2 to change our 2 hydrogens into 4 hydrogens. Okay, and then everything balances out just fine. As for reaction type, this is going to be a combination reaction. We have two reactants reacting together to make one product. So they are combining together. This is combination. Should put this in red. Combination. There we go. All right. Number 6. Oh, I did not mean to do that. There we go. Number 6. 2 hydrogens, 2 nitrogens. On the right, we have we have 3 hydrogens, 1 nitrogen. So the hydrogens are not balanced, okay, and the nitrogens are not balanced. I'm going to balance the nitrogens first, and here's why. If we try to balance the hydrogens, we have 2 on the left, 3 on the right. There's no easy number to multiply each of those to get like 2 into 3 or 3 into 2. But on the left, we have 2 nitrogens, and on the right, we have 1 nitrogen, and that one's pretty easy to change because we just need to multiply it by 2 on the right to give us 2 on the left. So we're going to put a 2 in front of the NH3. That will give us 2 nitrogens. That will then change our hydrogens from 3 to 6. And on the left, since our nitrogens are now balanced, but our hydrogens are not, this one now is a lot easier because we have 6 hydrogens on the left. We only have 2 on, we have 6 hydrogens on the right, 2 on the left, which means we're going to need to put a 3 there to change our hydrogens into 6. Okay, so there's our balanced equation. And as for the reaction type, it is just like the one above it here. It's just like number 5. This is going to be a combination reaction where, again, we have 2 reactants. 2 reactants that are reacting to make one product. All right, number 7. Let's take a look here. So we have 1 nitrogen, and we have 3 oxygens. Again, we have 1 oxygen here, plus the 2 oxygens here. Okay, so it's in 2 different locations, but total that is 3 on the left. On the right, we have 1 nitrogen, and we have 2 oxygens. Okay, so the oxygens are the only things here that are not balanced, and the nitrogens are. This one can be a little bit tricky if you're looking at it, okay? But whatever number that we put here in front of the NO is going to have to be the exact same number in front of NO2 because there's N for both of those, and those have to be exactly the same. So you might be thinking like, well, what should I do? In this one, you can just kind of guess and check. So let's just start by putting a 2 and just seeing if that happens to work. So let's put a 2 there. That will change our nitrogens from being 1 to being 2. Let's put a 2 then in front of this one because that has to change our nitrogens from being 1 to being 2. And then let's check our oxygens. So on the left side, we have 2 times 1, so that's 2 here, plus 2 there. That gives us a total of 4. And on the right, we have 2 times 2. That also gives us a total of 4. Everything balances out. Okay, so that one might seem a little bit tricky, but again, you can kind of sort of guess and check at the beginning, and sometimes it just kind of happens to work. And this one is going to be another combination reaction where, again, we've got 2 reactants reacting to make one product. All right, number 8. Balancing wise, again, we've got 2 aluminums, 3 oxygens on the left hand side. On the right side, we have 1 aluminum, 2 oxygens. So let's balance out the aluminums first. We're going to need a 2 in front of this one to give us 2 aluminums. And as for the oxygens, all right, so here's another one that's a little bit tricky. So there's no number that we can multiply 2 by to make it 3, okay, and vice versa. So instead, let's think of what is the first number that 2 and 3 multiply into that they have in common. That'd be 6. So if we can change this oxygen into a 6 by multiplying it by 3, like this, then we can multiply this one by 2 to change that one also into a 6. Okay, now that unbalances our aluminums because now we have 4 on the left, But we can easily change that by just changing this 2 to being a 4. And then everything is balanced out. Okay? All right. As for the reaction type, this is going to be a decomposition reaction. So right, decomp. We have one reactant breaking apart to make 2 products. Okay, last one here now. So on the left-hand side, we have 1 calcium. We have 2 oxygens because we have them in 2 different places. Okay, we have 1 here, 1 there, and we have 2 hydrogens. Okay, all right. On the right side, we have 1 calcium. Now the oxygen and the hydrogen are in parentheses, and this 2 is going to multiply them. So that gives us 2 oxygens and 2 hydrogens. Okay, because there's 1 of each of them in the parentheses, and the 2 multiplies each one. So just by looking at this, this is already balanced completely on its own. We actually don't need to do anything for it at all. It's already done. Okay, so that one's already done for us. And as for the reaction type, this is going to be another combination reaction because we have 2 reactants forming to make 1 product. All right, so those are all of them there. Let's move on to the more difficult ones, which is where we actually have to write out the reactions ourselves. Okay. All right, so for number 10, it says hydrogen gas reacts with iodine to produce hydroiodic acid. So we have to write out and balance the chemical reaction based on this description being given to us, and then identify the reaction type. All right, so hydrogen gas. So hydrogen is H. Remember, it is a Brinkelhoff. So it is H2. Let's actually zoom in here so we can see this a bit better. There we go. Sorry, this maybe it was too hard to see these up above. Hopefully that you can see them now. All right, so we have hydrogen, which is H2. Remember that hydrogen is diatomic. So when it's by itself, it's not just H, it's always H2. And it's reacting with iodine, which is I. Also a Brinkelhoff. So that one is I2. Again, if you don't remember Brinkelhoffs, like what is a Brinkelhoff? Those are all the diatomic elements. Okay, just to remind you, I'll write them here again. And the reason I say Brinkelhoff is because if you spell out Brinkelhoff, B-R-I-N-C-L-H-O-F, those are all the elements that when they're by themselves and not bonded with anything, they're diatomic. Okay, so bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Okay, those are all the ones that are diatomic. So we have H2 plus I2. We're making hydroiodic acid. So hydroiodic, that means one, it's an acid, so it starts with H. Iodic means it's with iodine. And since H is a positive 1 when it makes an ion, and iodine is negative 1 when it makes an ion, you just need 1 of each, such as HI. So this is our skeleton equation. It's not balanced. We can see that we have 2 hydrogens on the left and only 1 on the right, 2 iodines on the left, only 1 on the right. So we need to have a 2 in front of the HI to balance that out. And at that point, everything is done. And as for the type, this is going to be a combination reaction because, again, we have 2 products that are, or 2 reactants that are combining together to make 1 product. All right, number 11. Sulfur reacts with oxygen to produce sulfur dioxide. All right, so sulfur is S. Now, these are the Brinkelhoffs. These are all diatomic. Sulfur is not diatomic. It is actually octaatomic. So what that means is that when sulfur is by itself, it's S8 instead of just S. So it's going to be S8 plus oxygen, which is a Brinkelhoff. So that's diatomic. And that makes sulfur dioxide. So SO2. Okay, sulfur and then di for 2 oxygens. As for balancing, our sulfurs are not balanced even though our oxygens are. We need to have an 8 there to give us 8 sulfurs. That then gives us 16 oxygens, so we'll need to have an 8 there to balance that out as well. Okay, and everything looks good then. And then as for reaction type, this is another combination reaction. Combination, there we go. Again, we have 2 reactants making 1 product. All right, Number 12. Calcium acetate reacts with sodium carbonate to produce calcium carbonate and sodium acetate. So calcium is Ca. Acetate is a polyatomic ion. Okay, so let's just remind ourselves how we write chemical formulas. So calcium is Ca, has a charge of 2+. Acetate is a polyatomic ion, has a chemical formula of C2H3O2 and a charge of -1. So when these two go together, you're going to need 2 acetates to balance out the 1 calcium. All right? Because acetate is only -1, calcium is +2. So it's going to be Ca and then parentheses C2H3O2 and then 2 of them, okay, outside the parentheses. There's calcium acetate. That's reacting with sodium carbonate. So sodium is Na, charge of +1. Carbonate is a polyatomic ion, that is CO3, has a charge of 2-. So we're going to need 2 sodiums to balance out 1 carbonate, because sodium is only +1, carbonate's -2. So it's going to be Na2 CO3. Okay, so there's our sodium carbonate. And this is producing calcium carbonate. So we already have the ions written right over here, so we don't need to rewrite them again. So we have calcium carbonate, so that's Ca, that has a charge of 2+, with carbonate, which is 2-. So those are going to balance out in the 1-to-1 ratio. So there's just CaCO3. And then sodium acetate. So sodium is Na, acetate is C2H3O2. Charges are +1, -1, so those already balance out. All right, so there is, those are all of our formulas. We have to balance this. Calcium is good. We have 1 on the left. We have 1 on the right. Acetate. We have 2 acetates on the left, and we only have 1 on the right. Okay. Now, I know that there's a little 2 here, right? There's a 2 right on the oxygen. You go, oh well, look, there's 2 right there. See, and look, see, there's 2 right here as well. Those are the same. No, there's 2 on the oxygen. That's part of acetate's formula. Then there's parentheses, and there's a 2 outside parentheses. That shows that there are 2 big chunks of acetate. And on the right, there are no parentheses at all. That's only 1. So we need to put a 2 in front of this compound to give us 2 acetates to balance out the 2 on the left. That then gives us 2 sodiums on the right. And on the left, fortunately, we have 2 sodiums. So that also balances out the sodiums. And as for carbonate, we have 1 CO3 here, and we have 1 CO3 there, so that's already balanced. So this is all we need to do, just put a 2 there. All right, as for reaction type, this is going to be a double replacement reaction. So let's write DR. Because we have calcium swapping with sodium, so that in the products, calcium is bonded with carbonate and sodium is bonded with acetate. So double replacement. All right, number 13. Iron reacts with oxygen to form iron 3 oxide. So iron is Fe. Oxygen is O2. It's diatomic, so it's, again, O2. Iron 3 oxide, so iron 3. So we have Fe with a 3+ charge, bonding with oxygen, which is a 2- charge. Okay? So when those pair up, we need to balance our charges. We can do the Wonder Woman. Okay, so we're going to bring the 2 from the oxygen down onto the iron, the 3 from the iron down onto the oxygen. So we'll have a 2 down there and a 3 down there. Okay, so there's our iron 3 oxide. As for balancing, the irons are not balanced and the oxygens are not balanced. We can put a 2 here to balance out the irons. And then as for oxygens, there's 3 on the right, 2 on the left. The easiest thing is probably to both get them to be a 6. So let's put a 2 there to give us 6 oxygens. Put a 3 there to give us 6 oxygens. That then unbalances our irons. So this 2, which we had originally, is going to have to become a 4. As for reaction type, this is going to be a combination reaction because we have two reactants making one product. All right, number 14, iron combines with oxygen and water to form iron 3 hydroxide. So iron reacts with oxygen, which is diatomic, and water, that's what I meant to do, to form iron 3 hydroxide. Okay, so it's going to look something like that. The iron is positive 3. The hydroxide is negative 1. So you need 3 hydroxides to balance out the iron. As for balancing, this one is a little bit tricky. Okay, so let's make a list so it's a little bit easier. So you have 1 iron on the left. We have 3 oxygens. Okay, so we have 2 here and 1 there. And we have 2 hydrogens. On the right, we have 1 iron. This 3 is going to multiply the oxygens inside, so that gives us 3 oxygens. And it gives us 3 hydrogens. So the hydrogen is the only thing that's not balanced, as we can see. So let's balance that out first. And like we did in other ones, we're going to have to probably make this 6. So let's put a 3 there. Okay, that's going to give us 6 hydrogens on the left. Let's put a 2 there. That'll give us 6 hydrogens on the right. That's going to unbalance our irons. So here we have 2 now. And as for oxygens, we have 6. Because we have 3 times 1, that gives us 3 oxygens. And then times 2, that's 6. On the left-hand side, we have only 1 iron. So we got to put a 2 there to give us 2. And as for oxygens, we have 2 here. And this is 3 times 1. That gives us 3. So 2 plus 3 is 5. That's not balanced. All right. So everything balanced out except for the oxygens by doing that. So now we go, all right, now what? Well, I mean, let's just start guessing and checking. Clearly 2 didn't work. So let's just try 3, right? Originally it was 1. Let's just try 3. Let's put a 3 there. All right, so that is going to change our irons. We can put a 3 there. That will change our irons. Oxygen, or hydrogen, this is 3 times 3. That gives us 9 hydrogens there. Now over here, we only have 2. And we can't multiply 2 by a whole number to get 9, right? We have to multiply by 4.5. So just by doing this, I can already tell you that putting a 3 here isn't going to work. So let's go to the next one. Let's try 4. So that gives us 4 irons. So change these. This is now 3 times 4, right? 3 times 1 is 3 hydrogens, times 4 is 12. 12 hydrogens. As for oxygen, we have 3 times 1 times 4. That's also 12 oxygens. On the left, we need to get 12 hydrogens. So 6 times 2 will give us 12 hydrogens. As for oxygens, we have 6 times 1. That's 6 plus 2. That's 8. All right. So the oxygens are not balanced. However, this is easier to balance because we can put a number in front of this oxygen here, which will then be able to balance this out, and it won't change any other numbers for any other element other than just the oxygen. So right now we have 6 oxygens here. Okay, 6 oxygens there. Plus, we need to do some number of oxygens here, and those together need to equal 8. Okay, those need to equal 8. I'm sorry, they need to equal 12. Sorry, they need to equal 12 because we have 12 on the right-hand side. So question mark plus 6 equals 12. This needs to be a 6. Currently, right now, we only have 2. So to make this a 6, we're going to have to put a 3 there. Right? 3 times 2 gives us 6. Plus these 6, that gives us 12. That bounces up to 12 on the right. Okay. Now, just to make sure that we're done and everything looks good, remember that when we balance equations, all of these numbers need to be the lowest whole number we can possibly have. So is there a common number that we can divide out from any of these coefficients? No. Right? So like 4, 3, 6, 4, there's no common denominator between any of those. If it was like 4, 4, 6, 4, we could divide a 2 from everything. But we can't simplify this down any further, so this is our balanced equation. I know that one is a little bit tricky, but we got there. And as for reaction type, this is also a combination reaction. We have multiple reactants in this case, making one product. All right, so I'm going to write out the rest of these ones, I guess, really quickly. I won't take so long to explain them. Hopefully that helps. And again, if you have questions on 15, 16, 17, 18, let me know. I'm just going to go a little bit faster here so that this video is just going to wrap up. So, all right, here we go. Sulfur trioxide is SO3. Bubbled through water, H2O. Sulfuric acid is H2, SO4. In terms of balancing, this one is already balanced. We have 2 hydrogens on each side. We have 1 sulfur on each side. We have 4 oxygens on each side, so that one's good. As for reaction type, this is a combination reaction. Number 16, copper metal is made. Okay, so copper metal is made by treating copper ore the following way. So copper 2 sulfides is heated with carbon and oxygen to produce copper and sulfur. Okay, so we have copper 2 sulfides, that's CuS, and it's heated with carbon, so that's C, and oxygen, which is O, and it's diatomic, so O2, to produce copper, which is C, and sulfur dioxide, SO2, and carbon dioxide, CO2, right? So here's everything. As for balancing, coppers, we have 1 and 1. Sulfur, we have 1 and 1. Carbon, we have 1 and 1. Oxygen's the only thing that's not balanced. We have 2 here and 2 there. That's a total of 4. So we're going to need to put a 2 there to give us a total of 4 oxygens on the left. As for the reaction type, this one is kind of weird because there's a lot of different things going on. So we can kind of classify this in a couple of different ways. I would probably refer this as a combination reaction. We have sulfur combining with oxygen to make SO2. We have carbon combining with oxygen to make CO2. As well as we could consider this a single replacement as well because we have sulfur and oxygen, and the oxygen is essentially kicking the copper out, right? So the oxygen is like kicking the copper out to give us SO2, and the copper is by itself. So you could label this as like a couple of different ones, but combination or single replacement, this is one of those ones where it doesn't necessarily fall under one particular category. So, all right, number 17, copper turns black because copper combines with oxygen to form copper 2 oxide. So we have copper combining with oxygen to form copper 2 oxide, something like this. Balancing wise, we need a 2 there and a 2 there. And then reaction type is going to be a combination reaction. You might think maybe this is combustion because we have something reacting with oxygen, but combustion is specifically going to be something reacting with oxygen, and it's going to be a carbon-based compound, and we're going to make CO2 and water. Okay, so those are combustion. If there's not the CO2 in the water part, it's not combustion. So, all right, last one here. Magnesium hydroxide neutralizes stomach acid HCl to reduce magnesium chloride in water. So magnesium hydroxide is MgOH2. It's reacting with hydrochloric acid, which is HCl, and producing magnesium chloride. So there's MgCl2 and water, which is H2O. Okay, and then as for balancing, so by the way, for these ones, it's actually a little bit easier to balance this out. If we write it as, instead of H2O, let's write it as HOH, okay? Because here we have OH on the left, and so if we write it as HOH, we have OH on the right, and then we have H here and H there. So a little bit easier to see the numbers. All right, so let's make a list real quick. So we have 1 magnesium. Let's just count the OH as a group. So we have 2 OHs, 1 hydrogen, 1 chlorine. Okay. On the right, we have 1 magnesium, 1 OH, 1 H, 2 Cls. All right, so magnesiums are good. OHs are not. We have 2 OHs on the left, only 1 on the right. Let's put a 2 there. That'll give us 2 OHs. That also gives us now 2 hydrogens, so we need to change that. On the left, our hydrogens are not balanced now, so we need to put a 2 here to give us 2 hydrogens. That will also give us 2 chlorines, but that bounces with the 2 chlorines we already had over there on the right. So there is everything balanced out. As for reaction type, and after you've done that, if you want to change the HOH back into H2O, you can. As for the reaction type, this is going to be a double replacement reaction. So, all right. So that is it for this one, guys. Hopefully that helps. If you're having troubles, again, writing the chemical formulas, go look back at Chapter 9 videos. Again, that is the reason why you learn how to write chemical formulas first, so that when we start writing chemical equations, this is obviously more doable, okay? But that's it for this one. As always, if you need help from me, let me know. Reach out to me. I have no problem helping you. So, all right, guys, that's it. I will see you in the next video. Bye.